Hi, students, and welcome to our lesson today, where we are going to learn how to multiply monomials using something we call the product rule. But first, we have a do now, where we'll complete a chart about helpful and unhelpful thoughts. Our essential question today is, what is the product rule and how does it work? Our assignment today will be to complete our do now in teams, complete our work page. We have problems 17 through 38 today. We'll complete our exit ticket, and you must show your work to the teacher, and that's how you get your credit. If you do not finish within the allotted time of our class, you can finish it for homework. Remember, important, we are nearing the end of the third quarter. Are you showing your work to me? And have you completed all your quizzes? So for our exit ticket, we will ask you to complete the product rule. So here's our do now for today, still with all this St. Patrick's Day colors. Today, this is a scenario, a kind of made up situation. So we're going to say today is the deadline for turning in your class trip money, the deadline, due date, right? And you've forgotten again. Complete the chart with helpful and unhelpful thoughts. Okay, helpful thoughts and unhelpful thoughts, those come all too easy for us. You might write, oh, I can't remember anything. You might write, I'm just stupid. I don't know how I'm going to ever get a better memory. I don't know why I keep forgetting. How about a helpful thought like, maybe I should use an agenda and I should write things down. Maybe I can use the calendar on my phone to help me remember to bring that money in. Maybe I need to just spend a few minutes after school every day sitting and thinking about every one of my classes, 5 minutes a class, and just thinking, what is it I'm supposed to do? What is it I'm supposed to remember? And as soon as you think about, let's say if it's a music trip for music class, as soon as you think about that, you'll go, oh yeah, I have to bring in the trip money. So come up with a good idea on some helpful thoughts that you can turn this situation around. We talked so much this year about reframing things, and that's what we want you to do. We want you to just take those unhelpful, negative things, turn them positive, and become better while you're doing it. So let's get started with our multiplying monomials. We're going to use something today called the product rule, which goes like this. If we have a number and we raise it to an exponent, this time we'll call it a, and we multiply that by another number raised to another exponent, the answer will be that number raised to an exponent of a plus b. Now let me show you how that works. We're asked to find each product and express our final answers using positive exponents. So if we have 4 to the third power times 4 to the fourth power, remember when we talk about the product, that is the answer we get when we multiply. So we're talking about multiplication here. So 4 to the third times 4 to the eighth would be 4, and then we would add 3 plus 8, and that would equal 4 to the 11th. Now, if we use a calculator, that's going to come up to 4,194,304. But I'm just looking for you to do this. If we have negative 7 to the fourth times negative 7 to the fifth power, okay, when we multiply, we add the exponents. That's negative 7, and that will be 4 plus 5, the ninth power. 2 to the negative 6 times 2 to the second power will be 2 to the negative fourth power. Negative 6 plus 2 is 4. We are asked to use only positive exponents using our quotient rule. That would be 1 over 2 to the 4th, or we could call that 1/16. Number 20, 15, that's an invisible 1, times 15 to the 6th power. 1 plus 6 is 7, so that's 15 to the 7th power. 5 to the 9th power times 5 to the negative 1st power would be 9 minus 1, which would equal 5 to the 8th power. Number 22, we have negative 1 to the negative 2nd power times negative 1 to the negative 3rd power. That would be negative 1 to the negative 5th power, which we want to express with a positive exponent, so that would be 1 over negative 1 to the 5th power. Now, when we have variables, everything is the same. Nothing changes. So x to the 2nd times x to the 5th, 2 plus 5 is 7. That would be x to the 7th. M to the negative 1st power times n to the 3rd will be negative 1 plus 3, which equals 2. So that would be m to the 2nd power. So try 25, 26, 27, and 28, and then come back and check in the video. Meanwhile, I will work on them. So we have k to the negative 7th power times k to the 7th power. That would equal negative 7 plus 7 is k to the 0 power. Anything raised to the 0 power equals 1. Now we have a to the invisible 1st power. That's an invisible 1. A to the 3rd times a to the negative 9th. So that would be 1 plus 3 minus 9, which would be a to the negative 5th power. We're asked to use only positive exponents, so we'll put that under 1a to the 5th power. Number 27, x to the 4th times y times x to the negative 1st power. Well, we've got to keep the x terms separate from the y terms. So we have 4 minus 1, which equals 3. That's on our x term, and our y just has an invisible 1, and we don't write that. So that's our final answer. Number 28, s times r to the negative 2 power times r to the negative 4 power times s. Well, these s's have invisible 1s. So with the s's, it would be 1 plus 1 is 2, but with the r's, it's negative 2 minus 4, because we're adding the exponents, and that's going to equal negative 6. So that would be r to the negative 6, s to the 2nd power, but we have to have a positive exponent for the negative 6. So s to the 2nd power can become a numerator for a denominator of r to the 6th power. Now, if we have coefficients, our coefficients are those numbers in front of the variable. Like in number 29, we have a 4 and a 2. What we do when we have coefficients is first we multiply the coefficients. After we multiply the coefficients, we will simplify the variables using the product rule that we've been using. So 4 times 2 is 8, and we have a, 7 plus 3 is 10. 5 times negative 3 is negative 15. m1 plus 2 is 3, negative 15m to the 3rd power. So try these on your own, and then come back and look at the video, and let's see how you did. So number 31, we have 2w to the negative 1st power times negative 7w to the 4th power times 3w to the 5th power. So 2 times negative 7 times 3. So 2 times negative 7 is negative 14. Negative 14 times 3 is negative 42. And the w's, we have negative 1 plus 4 plus 5, which would be 8. And that's going to be our final answer. Number 32, we have visible 1 in front of the p. So 8 times 2 is 16 times 1 is still 16. So our number is 16, our coefficient. P to the negative 5 times p to the negative 1 times p to the first power, another invisible 1, negative 5 times negative 1 is positive 5. Positive 5 times 1 is 5. So, I'm sorry, negative 5 times negative 1 is positive 5. So that should be a positive 16p to the fifth power. So, oops, I know what I did wrong. I added wrong. Let's try this again. Negative 5 minus 1 plus 1 equals negative 5. Okay, p to the negative fifth power. So what happens? This goes in the denominator, 16 goes in the numerator, 16 over p to the fifth. Okay, number 33, we're going to multiply. Negative 2 times 6 is negative 12. And we have a, 1 plus 2, so that's a to the third. B, 1 plus 3 is b to the fourth, and that's going to be our final answer. We're okay with a negative sign in front, but we're not okay with a negative exponent. Number 34, negative 12 p to the eighth q to the negative 2 power times 1/3 p to the third q to the second power. So negative 12 times 1/3 is going to be negative 4. And p, we add 8 plus 3, which is 11. And q, we add negative 2 plus 2, which is 0. That's going to make that q to the 0 will be equal to 1. And since we're multiplying, it will go away because it is an identity. So we can eliminate that, and we can have negative 4 p to the 11. Number 35, 7c to the third d to the second power times 2cd times negative c to the third d to the eighth. So we have 7 times 2 is 14 times negative 1. We have an invisible 1 here. So that's negative 14. C would be 3 plus 1 is 4 plus 3 is 7. And then D, 2 plus 1 is 3 plus 8 is 11. And that's our final answer. Negative 14 C to the 7th power, D to the 11th power. Number 36, we have a negative 1, an invisible 1, 4, and a 7. Those are our coefficients. So negative 1 times 4 is negative 4. Negative 4 times 7 is negative 28. So for our A terms, we have 1 plus 8, that makes 9, plus 1 more makes A to the 10th power. Our B variable, we have 1 plus 2 more, that makes 3, plus 6 more, that makes 9. And as long as we don't have any negative exponents, that problem is completed. Number 37, negative 8k to the fourth power times 2k, there's an invisible 1 there, plus 3k to the second power times k to the third. Be careful, we have addition in the middle of our multiplication. So let's start with the left side of this addition sign. Negative 8 times 2 is negative 16. K times k to the first, 4 plus 1 is k to the fifth, plus 3 times 1 is 3, and k, 2 plus 3 is 5. So now we have negative 16k to the fifth plus 3k to the fifth, and we have like terms. They're both k to the fifth. That means we can combine those. So negative 16 plus 3 equals negative 13, and that's still k to the fifth power. And that is our final answer. And then finally, number 38, 9m to the sixth power times 2mn to the fourth power minus 4m squared n to the third power times 3m to the fifth power n. So we'll do the right side, then we'll do the left side, then we will subtract. So 9 times 2 is 18. M6 plus that invisible 1 is 7. N to the fourth, because they don't have any n terms over there, minus 4 times 3, which is 12. M2 plus 5 is 7. N3 plus 1 is 4. And now we have like terms, M7, n to the fourth. 18 minus 12 equals 6. And that's our like terms, m to the seventh, n to the fourth. So let's go back to our exit ticket, which asks us, how does the product rule work? When you multiply exponential expressions, you add the exponent. And let's do an example. So x to the third power times x to the fifth power will be x to the 3 plus 5, or x to the 8 power. And let's leave a warning. Watch out for invisible ones. Or invisible one exponents, because we don't want to forget those. So great job today. Thank you for working hard. Thank you for doing everything you need to do. Let's have a little fun with this St. Patrick's Day decorations here. There we go. Looks beautiful. Okay, have a wonderful afternoon. Thank you for your hard work. And remember, with practice, you'll be great.